Okay, I believe we're in section 64 now. Let's go there. And let's go through that same rigmarole. We're in section 64. The intent of this is to prepare you to do the exercises in 64. It's the 64th exercise. There's contents for you to look at, examples for you to do, or just to understand, and then time to reinforce the contents and the examples of doing exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. This document is being made available to the Prison Mathematics Project and the participants in that project. I realize there's other people watching these videos that aren't involved in that project, and you might be interested in getting this document. It's not published yet, but it will be published. My name is Bannon, and my email address is Bannon, and you probably should reach out to me to let me know that you're interested in getting more information about when it's going to be published. All right, that's my email address. B as in boy, the @ symbol, nnon.us. All right, let's talk through the section. They give me an example, and they tell me this is, just reading it, they say, and Wells is big on this. He's big on getting cases, like this case, that case. But I take a more, I'm not going to say he's not creative. He is creative, but I'm taking a different approach, all right? So I'm going to say he sees everything as a case, all right? So what does he say? This is a case over here. I'll read that to you, by the way. So it was in each equation of the second degree and homogeneous, that is, when each term involved the unknown number of the second degree in respect to the wow, that's a lot said over here. Here's an example of that case. All right. Then he goes through a method that he'd like you to follow. All right. Now, you may sort of like say, I don't understand why he's doing that. He's doing that because he finds that easy to do. There's nothing wrong with that, by the way. All right. So you should read through that and make sense out of it. If you like doing that, do it. All right. Do it. All right. Do it. I kid you not. Now, of course, when I do the problem, I'm going to do the same problem, by the way, slightly different. One thing I did notice that what Wells doesn't do, he doesn't graph it. I'll be graphing it. So we're going to do this system over here. And, certainly if I were looking at that system, the first thing I would be looking at, I would be looking for maybe an elimination or a substitution. And I realize that elimination is probably not going to work out too well. But I think a substitution might. And what I'm going to do over here, I'll point out what I mean by that. I'm going to take the first equation and solve it for y. And I'll be very careful about that. And I'll tell you what this is in the notes as well. So x squared minus 5 equals 2xy. And then I would divide both sides by 2x. What do you get? X squared minus 5 over 2x is equal to y. All right, I'm going to point out where this is in your notes. It's right over here. All right, so you got that part done. All right, now what would I do? Well, I would take this and I'd pop it in there. Let me go through that work with you. So what do you get? X squared plus, well, I got to be real careful now. X squared minus 5 squared over, well, on the bottom you'd get what? You square that, you get 4x squared. Again, we're squaring the y. We'll do that later. Equals 29. I guess I got to do some work here, don't I? So I think I would probably multiply both sides by 4x squared. And what would you get? You get 4x to the fourth. By the way, the problem's got much worse now. It's a fourth degree now. Much worse. What do you get over here? Plus x squared minus 5 squared. And 29 times 4, let's see, 80 and 36. Right, I'll write that down for you. 80 and 36. So 116, right? All right, I got some more work to do. And again, I'll look at the key later. But right now it's going to be 4x4 plus x4. I'm squaring that this term over here, by the way. Minus 10x squared plus 25 equals 116x squared. I've got some work to do here, don't I? 5x4. This is different than what Wells is doing. And I like to have options, by the way, and that's what we're presenting to you. I'm going to subtract this from both sides. And what would you get? Minus 126x squared plus 25. I want to go to the notes and see if I met that milestone. And the milestone I'm looking at this, and I see that right over here. I met the milestone. All right, now my next milestone is, can I solve that equation? And I got to be honest with you, it could be incredibly difficult. I could make a substitution, but I'm just going to try to factor it. And I like to do trial and error, and that's something different than what Wells would do. Wells, although he doesn't mention, he likes the AC rule. And I'm going to say, that's about the only choice for that if I'm using my fingers. And I like to use finger numbers first. If they fail, I got to use other tools. But I got the 5x4, and then I got 25. And I see the 120. I see it now. So it's going to be 25 and 1 minus. I'm still going to check. We do get 5x to the fourth. And then you're going to get minus 125 minus 1, which is minus 126. And minus 1 times minus 25 is going to be plus 25. So now I got two equations. Oh, by the way, I want to point out I met this milestone too. These are milestones. And now I'm going to solve these two equations because I'm using the zero product rule. And what's that going to be? I'll write this down for you. 5x squared would have to be equal to 1. I want to make this thing 0. And when would this become 0? When x squared is equal to 25. So what do you get over here? Well, this one's pretty easy to do. It's plus or minus 5. And this one over here, it's pretty easy to do. It's 1/5. And x would equal plus or minus 1 over root 5. All right, so I got troubles now. So what are your troubles? Well, I got 4 different x's to consider. All right, I want to make sure I can do it. All right, let me write this down for you. 4 different x's to consider. And I'm going to go easy first. I'm going to go with 5 first. I'm going to go at minus 5 next. These are 4 separate cases. And then I'm going to go with 1/5. And I'm going to go with minus 1/5. Now I got to figure out the y, then we got to check it. I want to point out what y is this thing over here. Right, x squared minus 5 over 2x. I'll write this down for you. Again, we just copied this over here. That's all we've done. Let's put this down. What's y going to be equal to? I'll be very careful here. 25 minus 5. That's 20, right? I'll write the scratch work on the side. And the bottom would be 10. This gives me 2. Let's put this one down. Y. And what do you get? Let's take a look at it. You're going to get 25 minus 5, which is 20. On bottom, you get minus 10. You get minus 2. All right, let's keep going. The 1/5 is more difficult to do. Oops, sorry about that. I'll get my eraser. Let's write it down. So what do you get? You get 1/25 minus 5, and then you get 2/5. I can multiply top and bottom by 25. And what do you get? 1 minus 125 over 10, which is going to be minus, this is y. I might be able to make a mistake, by the way. Minus, well, let me write this down. It's minus 124 over 10. And I'm going to just reduce it. Give me 1 second to reduce that. Get this out of the way. So what do you get over there? Let's see, I divide by 2, right? So minus 62 over 5. I'll write that down for you. Let's do this one over here. I got to get my eraser out. And I don't need to see my chicken scratch, but I need to do it. And when I write your notes up, there's a lot of chicken scratch before I write your notes up. Let's write this down. I'm doing minus 1/5, right? So what do you get? 1 over 25 minus 5. Again, we're doing this. Over minus 2/5. Multiply top and bottom by 25. Geez, deja vu. What do you get on top? 1 minus 125. What do you get on bottom? Let's see, minus 10. What does that give you? Minus 124 over, let's see, minus 10, right? And that's going to give you 62/5. Now, granted, I realize for a lot of students this is exhausting, and I want to see if I made a mistake yet. And I'm going to see if I met my milestones. And let's take a look at this. I had the 5, 2. 5, 2. I have minus 5, minus 2. And I made a mistake. Someone says, what mistake did you make? I took this down, and wishful thinking, I said this. This is not true. It's not true. So I got to get my eraser out. I got to erase all this nonsense here and say I made a mistake. I'm going to erase this over here, and let's write this down now. So what's the x? Again, my wishful thinking, I said it was 1/5. It's not that. It's 1 over root 5, or x equals minus 1 over root 5. Well, I got to do it again. I want to see if I get these milestones. Let's plug it in. And again, we're plugging it in here. And what do you get? 1/5 minus 5. On bottom, you get 2 over root 5. It's a lot of work, by the way. I realize that. And I got to do some work over here. I'm going to multiply top and bottom. You know what I'm going to do? I'll just write a little bit differently. I'll write it as 1/5 minus 5. And I'm dividing by 2 over root 5. Same thing as multiplying by root 5 over 2. I got to be careful here. So what do you get? Let's see. You get 5, and then you get 1 minus 25, which is minus 24, times root 5 over 2, which will give you minus 12, root 5 over 5. All right, we'll check it later. Let's do the next one. I'm going to get my eraser out. A lot of chicken scratch. I realize that. I'll plug it in. And what do you get? Again, we're plugging it in here. You're going to get 1/5 minus 5. And then you're going to get minus, let's see, what would you get there? 2 times that number, right? So minus 2 over root 5. Well, deja vu all over again. So 1/5 minus 5 times the reciprocal of that number, which can be minus root 5 over 2. And what do you get over there? Minus 24/5 times minus root 5 over 2. And what do you get there? Let's see, minus 12. No, plus 12. What am I saying? Because minus times minus is plus, right? Root 5 over 5. Whoops. I got 2's in my brain. We are now going to check our answer key, see how we did. I see this answer here. Well, actually not. Let me go through that with you. Get my eraser out. Rid my chicken scratch. People really don't need to see your simple arithmetic, but I do need to write it down, just like you need to write it down as well. All right? We need to write down our arithmetic. So I'm gonna write this 1 over root 5. And you would rationalize the denominator by multiplying by root 5 over root 5. That would give you root 5 over 5. So I'm pretty comfortable with that. I got this part over here. I got this one too, and I got this one. So it looks pretty good. What did I do in addition, though, to solving it the way I like to solve it? Again, I want to point out, Wells does it too. Wells uses his method. All right, nothing wrong with that. All right, you can do that. Now, certainly when you're writing things down, you might be confused by what he's writing down. Here's the deal. You might be confused what I'm writing down. You need to make sense out of something, by the way. Now, again, I like what Wells does. I appreciate what he does. All right, but a lot of times, although I appreciate what people do, I like to do my own thing. And that's what I just did. I did not do his technique over here. Although it's understandable, I did not use his technique. All right? What I do, I made a substitution. I thought it was easier. And I did. I thought it was easier. All right, that doesn't mean it's easier for you, which I just thought it was easier for me. Did I get the answers? Yeah, I got the answers. What I do in addition, though, that Wells doesn't do, and the reason he doesn't do it is they're not capable of doing it back then, and that's constructing a nice-looking graph. All right, and put this over here, and I want to claim to you, it's really time to think about these things over here, and I want to point out, what am I thinking about? I'm thinking about these two equations here. Now, this one over here, I'm going to go back over here. I want to point out that's that circle. All right, and then I did the circle, and this thing over here, although not well understood at this point, you know, that's going to be, well, you can treat it as a rational function. I guess that's the easiest thing to say. It's rational over here. All right, you can say it's rational if you want. And you get this graph over here. Let me just outline that for you. Oops, sorry about that. You get points of intersection, and I want to go through those with you as well. I got 1, 2, 3, 4. I clearly see 4 points of intersection. And I want to go through, I want to do the easy ones first. Like I think this one easy, just looking at the picture, it looks like 5, 2. That's that point there. And this is something you want to do on your own. So this one over here also looks like an easy point to me. It looks like -5, again, if you look at the x-axis, and -2 along the y. Let me do this one over here. Clearly I see a number that's between 0 and 1 for x, and I'm going to say it appears to be this point over here. But this would be tough to pull from the graph. I'll be honest with you, really tough. But I'm going to say 1 over root 5, comma, -12 root 5 over 5. What I would recommend you do is use a calculator to approximate those numbers. And I'm hoping when you do this over here, certainly just looking at it, it's a fraction, right? It's a small number. And this one over here, roughly speaking, -5 point something, all right? Let's talk about this point over here. Again, I'm looking at a picture. I'm trying to learn from that. Which is one going to be -1 over root 5, comma, 12 root 5. And you see some symmetry over here. Again, my recommendation, that's 12, I'm sorry, is to use a calculator to approximate those numbers. All right? So let's keep moving forward and see what he has next for us. Exercises. All right? Now, I got to be honest, when I'm doing the exercises, the way I do a problem, the way you do a problem may be different. Now, certainly the way Wells does a problem, the way I do the problem also may be different. But I try to do what I find to be easy for me. All right, so what I do over here, basically a substitution, very similar to the first problem we did. Right, you get a nice little picture. Very similar, right? It's almost really the same type problem. This one over here, and again, I'm looking at it. It looks like I did a substitution again. I just tend to like substitutions, I guess. I give you a nice picture. You should look at those pictures, pay attention to them. It may be hard differentiating, who's who in the picture, but clearly just looking at it, I think you probably know looking at it, there's 4 points of intersection. And it takes time to, just think through it, all right? This one over here, it looks like I did substitution again, right? Different what Wells would do. Oh, alternative way. Right? I talk about an alternative way too. I like alternatives, by the way, because sometimes I need to. And my techniques are not working. I got to find an alternative path home, so to speak. But again, we give you pictures here too as well. All right? 64, looks like I'm still doing substitution, but I do talk about an alternative method. And you may want to be considering that. I kid you not. What I'm going to say is the more time you spend thinking, the better. And yeah, it took me time to get to this problem set too. It takes time, by the way. What do you see over here? 2 points of intersection. This one over here, a little more interesting problem because I see those things they're rationals, and I clear it, and I guess I made a substitution again, and I got the 4 points of intersection. Was it work for me to get through the problems? You're not kidding. It's work. I do it though. I do the work. If you think there's any errors in my work, please point it out to me. I'm not saying I'm devoid of error. That's something I would never claim. I know I make errors. I spent a lot of time constructing a key though. And I'll be honest with you, that took me the most amount of time is constructing a key for Wells's work. He has some really great problems. There's no doubt about it. His problems are really, really good. Right? Much better than a modern algebra textbook. Modern algebra textbooks have really, they're really sailing towards the bottom. All right? Again, you can see my work, my answers. I give graphs for you. I outline the points of intersection. I also want to emphasize that when you're looking at Wells's answer key, in his original textbook, there were errors. And I think the reason for that, these problems are difficult. And the computer, whoever was doing that, when I say computer, it's actually a person, they made errors. Now, granted, someone's going to say it's too much work. It's too much work. We're at 13 already. Yeah, problem 13. All right, let me make sure it's 13. Make sure I said that right. Yeah, problem 13. And problem 13 takes up, looks like it takes up more than a page. Yeah, it took me time. All right, interesting looking graph over there too. All right, and what I mean by that, you can blow these things up. And, certainly I try to, indicate what the points of intersection are. These are graphs that are very hard to differentiate. They look very similar. I'm sorry. Related sage code. What's Sage? It's a computer algebra system, or a CAS. It's open source, which means free. Free to download, free to use, by the way. Download it, or use the interactive web-based application. Type some code in over here. See if you can understand it. And by the way, that's tough. This is not about using Sage, though. This is just introducing to it. What I'm going to claim, though, is we'd like you to do what Wells wanted you to do, which is these problems over here. All right? And these are the cases that he likes. Right? He outlines it in his notes about what the case he likes. And you can use this technique. I'm not saying you can't. What I can claim, though, is if you find any errors in my notes, please reach out to me. My name is Bannon, and my email address also looks like that. B as in boy, the @ symbol, then NNON.US. Yes, I'm in the United States. Any questions or concerns, or you're pointing out errors, please reach out to me. I love hearing from people. And by the way, the community will benefit by your careful looking at the notes. Thank you.